Hi, I'm James Jackson. In my free time, I serve as the Volunteer Director of Technology at OpenAR Cloud. My interests are around large-scale distributed systems, as well as using computer perception to solve global problems. So this lines up very nicely with the concept of an open spatial web, with a world that's painted in data. We can think of it as an evolution of the existing web that binds to core principles such as decentralization, openness, interoperability, and privacy. And when all of these come together, we can create some truly amazing experiences that put end users in control. Within OpenAR Cloud, my main focus is on the technology direction for the Open Spatial Compute Platform, OSCP. And I'm going to spend most of my time talking about what this looks like under the covers. Before I start, I should mention that OpenAR Cloud is a nonprofit. We're not seeking to operate commercial services, but rather to steer standards direction and create open source reference implementations. So this is a high-level architecture view of OSCP, and it's a rather busy picture, but I'll try to simplify it a bit. Let's start with a user. Imagine I'm wearing lightweight 5G AR glasses and walking through a city. We'll step through the various stages that enable an open spatial web. So the very first step is finding out which spatial services are available to me in this city. We call this spatial service discovery. And similar to a DNS hierarchy, it might be scoped to a country level, like a country top level domain. In its simplest form, this is a mapping of coverage areas and corresponding services with standard APIs. Some of those services are shown here, and they're scoped to subregions such as cities, generally expected to reside close to the end users in some sort of an edge cloud. So let's move on to the second step. Now that I have a list of spatial services I can use, I need to find my Geopose. What is Geopose? It's a highly accurate representation of my position and orientation, where am I facing, in a common real-world coordinate system. We're working with the Open Geospatial Consortium, or OGC, on standardizing this representation, and we're also developing a standard Geopose localization protocol, which has already been implemented by some of our partners. Today, this positioning for AR is largely a visual problem, using cameras along with other sensor data to localize yourself into a pre-built map of the world. But in the future, there will be other important technologies that come into place, such as 5G positioning. So now that we know precisely where I am, we can move on to the next step, which is discovering spatial content or spatial experiences that I'm interested in. We call this spatial content discovery. This is sort of like democratizing search in the open spatial web. It has a decentralized architecture where multiple providers contribute to a common shared index. So if I place content publicly in the real world, that content should be discoverable by anyone. It shouldn't be restricted to those who are using specific services or specific implementations. It's sort of like publishing a web page. Spatial content records are just lightweight references to content and the associated geopose for that content. The actual content itself most likely lives elsewhere, as shown here. So if we move to the final phase now, this involves accessing and rendering the spatial content or spatial experience. And there are a few different pieces that have to come together. There might also be a cloud rendering service involved, such as NVIDIA's Cloud XR. But the piece that's most relevant to OSCP is the reality modeling language. This is where that highly accurate real-time digital twin of the real world lives. So why do we need this? Well, rich immersive experiences need to be able to interact with the real world in a seamless manner. If we look at some of the AR experiences we have today, they're rather limited in this regard. One of the simplest use cases might be occlusion. As an example, if I discover some spatial content, but there's a tree between me and that content, I really shouldn't be seeing it. But you can imagine that with really rich, real-time, machine-readable representations of the real world, you could build some incredible experiences. At the same time, we have to be really careful about the privacy implications associated with this data. So with that, I'll wrap up. Thank you so much for your time, and we look forward to seeing you join us on this journey to build the open spatial web. Thank you.